Parental functions. Absolute value transformation. First transformation. The first transformation we will see is how the graph gets narrower or wider according to the x value. In this image, we have the absolute value of x, or when x is the same. You see, it has a diagonal direction and forms a kind of V in the first two quadrants. But if we change the value of x into 2x, the graph gets narrower, and as we add more and more value to x, the graph gets more narrow. But now, how can we make the graph wider? Well, as you can see, when the x value gets closer to 0, it gets narrower. We have 0.9x, which is closer to 0 than 1, and it opens more. Second transformation. And what if we want the graph to go in the negative quadrants? To do that, we will need to add a negative sign to the current equation. As an example, we have the same equation g equals absolute value of 0.9x, and we will add the sign outside this absolute value. And as you could see, the equation goes downwards. Third transformation. For the third transformation, we will see what happens when we add a number to x inside the absolute value. For this purpose, we will have the initial equation, absolute value of x, and we will add 2. As you could appreciate, it moved towards minus 2. See that the 2 is negative in the x-axis. And finally, to make the graph move to the positive side of the x-axis, we will need to change the sign into a negative one. In the equation g equals absolute value of x plus 2, we will change it into g equals absolute value of x minus 2. And as you see, it moved to the coordinates 2, 0. Fourth transformation.
For the fourth transformation, we will see how, depending on the numbers placed in the equation, the vertex of our function will change the position of both the y-axis and the x-axis. To begin with, we will use a neutral equation and start modifying it at the beginning to move it on the y-axis. At the moment of placing this equation, we realize that the function has moved 3 spaces up the y-axis, but if we modify the same equation placing a negative sign, we will have a different result. We will see how our function goes down to the minus 3 line of the y-axis with this equation. Now, for the fifth transformation, to make our function move along the x-axis, what we have to do is modify our equation again as follows. In this way, we can see that our function stays in the same line of the y-axis but changes for the x-axis. Here we can notice how it had moved to the minus 2 line of the x-axis to make our function move to the opposite side of the graph. What we have to do is modify the sign of our absolute value. And in this way, we can see that our function has moved to the same point but to the opposite side of the graph.
We hope you really enjoyed this video. The video was made by Gabriela, Angelina, Bernal, Ibañez, and Fernanda, Fabián, Cruz.